Episode 24 of the WildFed podcast, Tick Check, Preventing Tick-Borne Illnesses with Dr. Stephen Rich, is brought to you by Surthrival. Fortify your immune system with scientifically validated nutrients, functional foods, and herbal medicines that give you confidence and peace of mind. Vitamin D3 is critical to immune function, and after a long winter, most of us are running low on the stores we built up from sunlight exposure during the warm summer months. There's a study in the peer-reviewed medical journal BMJ called Vitamin D Supplementation to Prevent Acute Respiratory Tract Infections. Here are the article conclusions. Quote, vitamin D supplementation was safe and it protected against acute respiratory tract infections overall. Patients who are very vitamin D deficient and those not receiving bolus doses experienced the most benefit. Close quote. Surthrival's vitamin D3K2 is derived from lanolin and Japanese natto, and the dose is just 2 drops per day. I personally take vitamin D3 daily throughout the autumn, winter, and spring, the times of year when I just can't make enough from natural sunlight. Additionally, check out Surthrival's other immune-building formulas, like their dual-extracted chaga medicinal mushroom formula. Chaga has demonstrated powerful immune-modulating activity. You can find a scientific literature review on chaga on the Surthrival website. Lastly, take a look at Surthrival's colostrum, an immune-fortifying functional food that I use daily in my morning blended drinks. I've mentioned several times now a study hosted on PubMed called Prevention of Influenza Episodes with Colostrum Compared with Vaccination in Healthy and High-Risk Cardiovascular Subjects. The following is from the abstract, quote, colostrum, both in healthy subjects and high-risk cardiovascular patients, is at least 3 times more effective than vaccination to prevent flu and is very cost-effective, close quote. Colostrum has long been used to create a robust immune system. Remember, a strong immune system is always your best defense. Check out the lineup at surthrival.com. And if you love this podcast and you want to see the WildFed TV show, head over to wild-fed.com to see episode 1 on the river floodplain. Since we're all spending a bit of extra time at home, we've decided to make the episode free for you to watch. If you like the episode and you want to see more, you can use the coupon code HUNKERDOWN, that's all one word, HUNKERDOWN, for 25% off Season 1 or the Season 1 and Director's Cuts bundle package. Season 1 on its own is just over 4 hours of premium TV, and the Director's Cuts are an additional 14 hours of content with in-depth discussions about the episodes and how we use the equipment and strategies you see there. Again, go over to wild-fed.com to see episode 1 for free and to get the links to the Vimeo pages where you can use the coupon code HUNKERDOWN for 25% off. This is an ideal time to watch the season or individual episodes, especially with the upcoming hunting, fishing, and foraging seasons all about to start. And hey, to all of you who've gone and watched the episode, thanks so much for your support. If you liked that show, please share it with your friends. I'm Daniel Vitalis, and you're listening to the WildFed podcast, a show about reconnecting with nature through hunting, fishing, foraging, and food. WildFed. Food is all around you. So I went back and forth on whether or not to release this interview today. I kept asking myself, is this appropriate right now? On the one hand, the tick season is upon us. Those of us who spend time in the outdoors, particularly those of us who step off the beaten path, need to maintain both a current scientific awareness about ticks and tick-borne illnesses, as well as a seasonal situational awareness. By that I mean going beyond bug spray and tucked-in socks. We have to body check regularly, starting in the early spring and maintaining that vigilance all the way through to summer and again in the autumn, continuing right up to the winter. Otherwise, we significantly risk contracting a tick-borne illness, some of which can be quite serious. Now that said, at the time of this recording, we are elbow deep in the COVID-19 pandemic, and I worried that this podcast might come across as more bad news. The very last thing I'd ever want to do, especially after having been cooped up in quarantine, is to scare anyone from spending meaningful time in nature. To be honest, ticks gross me out and I'm pretty adapted to them, so I can only imagine how off-putting this information could be to someone who's less acclimated to them. I really didn't want to send the message that in addition to not going into social and urban environments because of the pandemic, you should also avoid nature because of ticks and tick-borne illness. Now, of course, that is not the message anyway. This message is one of empowerment. Empowerment born from scientifically vetted education and situational awareness. I want you to spend time in the natural world, and I want you to remain healthy while you do it. In the end, I decided to release the interview knowing you're all mature adults who can handle knowing about the threats in your environment, even when they are, unfortunately, stacked. So yes, there's a very real and acute health threat that you must be aware of right now in the built and social environment. And of course, there's also the threat we'll be discussing today out there in the natural world. This show, WildFed, is about a lot more than just hunting and foraging. It's really about becoming adapted to your environment. Like many animals who must remain vigilant at all times lest they become a meal, we must remain alert as well. Our environment contains many threats, both visible and invisible, and it always has. The challenge we face is having grown up during a relatively safe period in human history, and most of us in places that have been exceptionally sheltered from threats that would otherwise be a normal part of living. We in North America, at least, have lived in a lull between some otherwise intense moments in the human saga. So while many people would have you believe that the world is largely composed of rainbows, unicorns, and pixie dust, and others would contend that the world is a threatening and dangerous place full of crime, disease, and starvation, I prefer to walk a middle path. Unafraid to confront the very real perils that are an unfortunate consequence of living, and also being eyes open to all of the beauty, opportunity, and interpersonal love and caring that exist here too. These two sides of the same coin were never mutually exclusive. All that to say, if you want to cook with fire, learn to use a fire extinguisher. If you want to drive a car, learn to use your seatbelt. If you want to hunt with firearms, learn to use a tourniquet. If you want to explore the outdoors, you need to learn about ticks. Not urban legends or bro science either. Instead, listen to the folks who are doing the actual work. Not because of some appeal to authority, but rather to avoid the many misunderstandings that are so rampant amongst the uneducated and those that parrot them. So I'm trusting that you can both live in this temporary dystopia of pandemic lockdown and simultaneously can also handle learning about the perils of tick-borne illness, because getting outside to avoid COVID-19 and instead contracting Lyme disease or any of the other so-called co-infections would just be ridiculous. And besides, this is no time for a hospital visit, especially if it could have been avoided with some simple preventative measures. Which brings me to today's interview. Dr. Stephen Rich is a professor of microbiology and director of the Laboratory of Medical Zoology at the University of Massachusetts Amherst. He's also the director of TickReport, a professional tick testing service for public individuals and agencies seeking more information about the risk of dangerous pathogens. He's authored numerous scientific publications, and his research focuses on zoonotic disease, in particular Lyme disease and human malaria. You can find his work at TickReport.com and tickdiseases.org. Next week's interview is with Tim Nedler, fish culture supervisor of the New Gloucester State Fish Hatchery of Maine's Department of Inland Fish and Wildlife. He both grows and stocks trout, and I visited him to learn more about stocked fish. How are they grown? What do they eat? And most importantly, are they worth fishing for and eating? What I learned really surprised me, so tune in next week for that. Now, enjoy this interview with Dr. Stephen Rich, which I think you'll find incredibly insightful. In fact, I hope you'll share it with your friends and loved ones, especially those who spend time in the outdoors. My wife Avani and I have a salutation we use during tick season whenever we say goodbye to each other. It's said in the spirit of health, well-being, and in the support of outdoor adventure. It's that time of year now, so I'll say it to you. May you feel every tick. Well, we are down at the University of Massachusetts at Amherst, and I'm here with Dr. Stephen Rich. And Dr. Rich, we spoke about a year and a half ago. I interviewed you on the topic of ticks and tick-borne illness and the services you guys offer here. But that was over the phone, so it's exciting to meet you face-to-face. Thanks for taking the time today.
Glad you guys could come.
We were just joking in the parking lot. I kind of had this sense of like one of those comedy movies where two old guys show up on a campus, don't realize how old they've gotten, you know, like I had my backpack on when we think of ourselves as kind of young and fresh, and then I was looking around and I was like, oh man.
That's my everyday.
That's funny. Tell us a little bit about what you do here at the university, and let's talk about TickReport.com as well, and what you guys do.
Okay, so TickReport is one of the services at the Laboratory of Medical Zoology, which is the laboratory housed in this building. We focus in the laboratory on zoonotic diseases. So these are diseases that are in wildlife populations and that spill over to people. So they're unlike things like measles and human malaria, which are our species diseases. They're actually other species diseases, and then they spill over into our species.
And that is separate from the diseases that would be in domesticated animals, or is that inclusive?
No, that includes domesticated animals as well. In fact, domestication is one of the reasons that we have as many diseases as we have.
Right. Yep.
So Laboratory of Medical Zoology focuses on zoonotic diseases, including ticks and tick-borne diseases. And several years ago, we started opening the doors to the laboratory and making the services available, what we do internally, available to the public vis-a-vis the tick testing service, which is TickReport. So now, in addition to testing ticks ourselves for our own hypothesis-driven research, we're trying to figure out how things are working in nature. We make some of the same methodologies available to people that want to understand better what happened in their tick bite, how long did the tick feed, and what pathogens were involved with that bite, because that's an important way of determining how risky that tick bite was.
So in other words, people can send their tick to you, get analysis done, and know a bit about...
Our tagline is, you can send a tick to college.
That's good. That's good. And then outside of that, what is it that you do here at the university?
So in the lab where we're studying the pathogens, we're also interested in ways of controlling pathogens, killing pathogens, so new therapeutics, ways to limit the number of ticks, so new ways to kill ticks either chemically or in some cases maybe use the immune system of the things that they're feeding on to kill the ticks.
How'd you get interested in zoonotic disease? Kind of that's like a very specific
so I started because I was interested in mice. I thought mice were fascinating. I was interested in mice in Maine islands and how they got there and how they diversified as they got isolated after the last glaciation. And there wasn't a lot of money to support that kind of curiosity.
Mm-hmm. Right.
And it turns out it was an emerging area of Lyme disease. And so that funded my research initially. And as I was going about doing my research, I became interested in the Lyme disease and the emergent areas of tick-borne disease, and one thing led to another.
Over the course of your career looking at this, could you kind of give us a bit of like a timeline of how Lyme came into public awareness, and then maybe sort of what you've seen trending over the course of the time you've been looking at it?
So the whole Lyme thing started in the mid-1970s with not physicians, not public health officials. It was a group of concerned mothers that noticed a bunch of sick kids, and they brought it to the attention of the public health officials that eventually came in to do the investigations. I was 10 at the time.
Okay.
And what was notable about that occurrence was that there weren't, prior to that period, a lot of ticks in southern Connecticut, or the particular species of tick, which we now call the deer tick or the black-legged tick. And so when the investigators came in to study that pathogen or that outbreak of disease, they noticed this commonality that most of the kids that were getting sick with this juvenile rheumatoid arthritis had been bitten by ticks. Okay. And so from there, the mid-70s through...
So that was the symptom, was juvenile rheumatoid arthritis.
Juvenile rheumatoid arthritis.
Okay,
so you get kids with arthritis.
Inflammation in their joints.
Mm-hmm.
Yeah. That and it being... so it's inflammatory, but rheumatoid refers to it that it's an immune system response, right? So rheumatoid arthritis is more of like the body is responding or attacking its own joint sites.
So your body has immune response to lots of things, sometimes pathogens in this case, and if that response is not appropriate, for lack of a better word, then it can lead to pathologies.
Okay. And so, that's just really interesting to me. They must have had spirochetes in their joints.
Spirochetes in their joints that were probably inducing this kind of reaction.
Okay, but to the doctors looking at it, looked like rheumatoid arthritis.
Right.
Okay.
So then for the next 10 years, investigators were trying to understand what was going on with that. The first tick bite etiology, they knew it was associated with tick bite. They identified a new pathogen, which is the spirochete that causes the disease, and then eventually figured out the whole life cycle. But it took 10 years for that to follow. So by 1985, the whole picture was understood. And really, not a heck of a lot has changed since 1985. We understand how we get it. We understand where it comes from. We understand a little bit about how to kill it early on, and probably the only thing that remains controversial is what happens when you don't knock out the infections early on.
Right. I'm noticing, I dabble in emergency medicine, and I'm just noticing now, I just did a run through a wilderness first aid course recently, and I started to finally see some stuff about ticks filtering into the coursework and curriculum. But for me, over the last 20 years, it seems like it's just kind of breaking through the haze that most people live in to like where people are becoming aware of it. I guess, I know people have been aware of it, but I feel like people are now much more concerned than they were 5-6 years ago.
It depends on where you live, so it can be very localized. So in places like Cape Cod, they've known ticks for 40 years.
Sure, okay.
The kids know about it, the parents know about it, the grandkids know about it. But you go to places where I grew up in upstate New York, just starting to figure it out and just starting to become aware of it. The level of preparedness isn't the same. The level of anxiety and the response is much higher there.
And I want to talk for just a moment, because I'd like to come back later and circle around to talking about the specific bacteria, viruses, and protozoa as well that people can pick up from ticks. But just so that the listener gets it from the outset, Lyme is just one of the diseases that is transmitted by these ticks, right? So there's actually several others that get lumped into this idea of co-infections, right? But what are some of those, and how serious are they?
So the first thing to know is that Lyme is just one of them, but it by far and away is the most common. So as many as 50% of the adult ticks are infected, and that's extraordinarily high. Probably the next most common would be Babesia microti, which causes a malaria-like illness called babesiosis. Lives inside your red blood cells like malaria parasites. Has been involved with transmission through blood transfusions in addition to tick bites. Wow. So tick bite victims can then be blood donors, and then it gets into the blood supply.
Okay. Do they screen now?
They screen now very, very well. And that can cause a serious illness, febrile illness. It can be treated much the same way as malaria.
Okay.
It's one of the pathogens among the list of all the ones that we'll talk about that is not a bacterium, and so isn't treated with antibiotics. And so most of the other things, with the exception of the viruses, can be treated with the same antibiotics. Okay. Second on that list would be Anaplasma phagocytophilum. Unfortunately, they don't have nice household names, but it causes something called anaplasmosis, which also lives inside, in this case, your white blood cells, which makes that pathogens that live inside your cells are particularly insidious, especially the ones that live inside the cells that are supposed to be protecting your body.
Yeah, right.
So anaplasma has achieved that trick.
Also causes
Trojan horse, and it can be a febrile illness as well. And probably results.
Febrile illness means
a fever causes fevers. Many of these things are associated with fever. Not the rash that you'd see in Lyme disease, but the fever. Maybe 5% of the ticks, 7% in a really highly endemic area, have these pathogens. And then from there down, we go down to things like Rocky Mountain spotted fever. There's Powassan virus, but all of these are, while very serious illnesses, are very, very rare, vanishingly small. In the case of Rocky Mountain spotted fever, Powassan virus may be less than 1% of the ticks. We think that actually a number of ticks that are infected that bite people don't end up with resulting in disease, in much the same way that many of us get bitten by...
What was that number again you just said?
Less than 1%.
Of people bit by ticks?
Less than 1% of the ticks are infected with Powassan virus.
Oh, understood.
And among those people that are bitten by those 1% of the ticks, probably a vanishingly small number of those actually develop
so transmission rate's very low in...
Illness rates.
Illness rates are very low. They still then are contracting the Powassan, but they don't manifest.
It's too early to say. So it may or may not be that they're getting infected. But we liken it to West Nile virus. So West Nile virus was a zoonotic disease outbreak in 2000, quickly spread across the country, all 48 continental U.S. states. Most of us, not most of us, but many of us have been exposed to it by a mosquito bite, have antibodies against it, but never had visible signs of illness. Powassan may be that way. We know about Powassan because there are cases where it ends up in an encephalitis case, and those are notable. They get in the New York Times or the Boston Globe because encephalitis is a terrible thing, usually irreversible. But but probably that's just a small percentage of the people that actually get exposed to it.
And just for the listener, we're talking brain swelling, right?
Brain swelling, sorry. Yeah.
I think, though, I feel Grant over to my left here just relaxing a little bit, because on the drive here, he was really getting bugged out about the idea of Powassan. He's searching it in his phone, and he's like, how many cases have there been in Maine? I was like, oh, not many. I think it was like 5 or something. He's freaking out. He's like, it's only 2. It's only 2. Like, when are those articles from? The black-legged tick, the dog tick, and now the Lonestar tick are really our 3 big culprits, right? So I want to just sort of, for those who are biologically minded, there's a much larger group of species, right, who live here in the Northeast. And I don't know what your knowledge is about distribution throughout the country or the continent. Is that something you're able to speak of roughly at all? Because I'd love to hear a little bit about, I know that I'm asking you a bunch of things here. One thing I'm curious about, do all these ticks belong to one group or one family in taxonomically?
They are a single group. They're called hard ticks.
Okay.
They're distinguished from soft ticks, which usually are nest parasites, so we never see them.
These are the other tick species that I read about that are in the nests of chipmunks and woodchucks and things like that. Those are soft.
Yeah, not to put too fine a point on it, but they're also hard ticks that are in that circumstance that we never see them. So there's woodchuck ticks, which ostensibly, if you held them in your hand, you probably wouldn't be able to tell them from a deer tick.
Oh, interesting.
They very rarely are found on people because they spend time in woodchuck burrows.
Right.
They will bite people on occasion, but not so often.
Okay.
There's squirrel ticks, there's fox, there's all kinds of different ticks that are out there that we just don't see. So what sets those 3 apart is they're the predominant human-biting ticks in the Northeast.
Okay. For people who do interact with animals like squirrels, and I hunt squirrels every fall, so I interact with squirrels physically several times a year. Do I run any risks of running into those ticks, or are they primarily in nests and nest sites where I won't really be?
Because ticks feed the way they do and not the way a flea does, they pose little risk if you are handling the animals. If you were handling a carcass of a squirrel, the fleas could fall off, they could get on you, and they could bite you.
Sure.
The ticks that are feeding on that squirrel, they're either going to die with the squirrel, or they're going to fall off. If they were close to having fully fed before the squirrel was killed, then they would fall off, and then they'd have their life. But they're not going to fall off and be ready to take
ready to eat again. Yeah, I got it. Okay, so our big 3 then that we're dealing with are going to be the deer tick, the dog tick, and the Lonestar tick. Are they endemic here, or have they had range expansions that have brought them here? Because I talked with you the last time about my own just anecdotal experience of had been outside a lot throughout my life, but not really seen ticks like I see now until really the last decade or so.
So dog ticks are probably always, and when I say here, I'm going to think about the Northeast predominantly.
Okay.
So dog ticks have been widespread throughout the Northeast probably as long as pre-Columbian times.
Okay.
Deer ticks, or black-legged ticks, they probably had a very restricted range. And what we've seen is an expansion from a couple of relic populations, perhaps on coastal islands, Elizabeth Chain Islands in southern New England. The Lonestar ticks are an altogether new thing. They're predominantly found in the southeastern United States and are clearly now expanding their range northward.
Okay.
Now, whether that's due to climate change, it's too hard to say. There's a number of different factors that have changed ecologically, unrelated to climate change, like the fact that there are far more deer in the Northeast than there ever were before.
Deer are part of
the feeding cycle for those guys as well.
The name Lonestar I associated with Texas initially, but does it refer to actually some pattern on their back?
Yeah, it's a morphological feature on the back. They have very
okay, so nothing to do with Texas.
No.
That helps clear that
They're
off
the hook.
Yeah, Texas, it's not you. That idea, though, of more deer and edge habitat is interesting because the changes that we've seen since the last ice age in North America, going from this, where white-tailed deer were a relatively small population competing against animals like elk, and we had obviously wolves here, and
predators.
Yeah, of course. So not necessarily the conditions of climate change, but more like the conditions of habitat change that have happened by just people inhabiting everything and pushing urbanization out has created ideal conditions for the tick as a byproduct of creating good conditions for deer then?
Where we're sitting here looking over the Berkshires, it was all clear cut. 150 years ago,
Right.
clear cut for farming land, and then we let it grow up into pasture
Okay.
land and lots of edge habitats and stone walls, which
Okay.
are perfect for deer,
Okay.
ticks. Deer, white-footed mice and deer
Yeah.
ticks.
Okay, so we're actually creating the ideal conditions for these ticks.
We've done it. Yeah.
Okay, now the dog tick, the one that I encounter most frequently, it's not odd for me to have 20, 30 on me in a day. Sometimes, I mean, I just see so many. If we were to just drag a T-shirt through my backyard, we'd pick up 100 of them. I mean, there's just so many. They are reservoirs for some of these diseases, but do not transmit them. Is that accurate?
They are vectors. So reservoirs we usually reserve for the mammals.
Oh, thank you. Okay.
But they are vectors of different pathogens, and they do transmit them. It's just that the infection rates are very
low.
very low.
Okay. Because I've been under the impression if bit by one of those, that's not a tick. I usually hear people talking about sending in or needing to get analyzed. I've not heard of anybody getting, it's not like I have a huge, group of people I've interviewed about this, but I haven't heard a lot of people contracting anything from dog ticks.
So dog ticks can give something called tularemia, Francisella tularensis, which is can be a bad disease. But again, it's a very, very, I think in 54,000 ticks that we've tested, we've seen 5 positives.
Okay.
Wow. They can also be associated with Rocky Mountain spotted fever, which also is relatively rare in those ticks.
But it's then the deer tick. Let's talk about them a little bit because they seem like, and you've got this plush toy here of a deer tick on the table. We walked in and saw this. It's for you listening, it looks like and is sort of styled after a Beanie Baby, but it's a rather large and creepy looking deer tick. So this tick, the black-legged tick, is the one that I get the most creeped out by. I find quite a few of these as well. My guests find them on. The dog brings them into the house, and they're the ones that I'm in front of the mirror 2, 3, 4, 5 times a day, all spring and all fall because of. Tell us a little bit about them.
So she's about the same size. So one of the misperceptions is that they're much smaller than dog ticks. In fact, she's about the same size as a dog tick as an adult, but as a juvenile stage, she'd be much smaller. She'd be more the size of a sesame seed as a juvenile stage, and then as a larval stage, she'd be just about the size of the head, or maybe poppy seed size. So they are a little bit smaller, but most of than dog ticks. But most of the differences are between age groups rather than between tick species, and ironically, they're not as robust a tick as the dog tick. So dog ticks can do things called they can diapause, so they can basically go into a kind of torpid state where they don't, they're not affected by dry conditions or an abundance of heat. These guys aren't.
They're
as
also
robust
resistant to freezing. No?
Yeah, these are resistant to freezing as well, but they rely more on the ability to crawl up and down in the leaf litter to sort of find the right micro.
So they're thermoregulating.
Yeah.
Whereas the dog tick can kind of do that physiologically.
Exactly.
Okay. But that doesn't seem to mean that they just die off either, do they? Because I find them while there's snow on the ground.
It's probably a numbers game. So they're probably dying off in great numbers.
Okay, got
but
it.
because she's
so
going to lay
many.
3,000 eggs.
Yeah.
And those 3,000 eggs are going to turn into 3,000 larvae.
Right.
And a single deer can feed thousands of them. This is the fun of talking.
And they can
about
transmit disease at any stage in their life cycle?
except the larval stage. In the case of Lyme disease, they're born without the Lyme disease, and they have to acquire it from one of those reservoirs.
At the larval stage, are they morphologically still like, do they still appear like a tick or do they look different?
They're similar, except they have 6 legs.
Oh, interesting.
So they're so these are not insects; these are arachnids. So they have 8 legs. But
okay, so all the ticks are arachnids.
Yeah.
Ah, okay.
So as larvae, they have the neotenic feature of having just 6 legs, which is like an insect.
No kidding. Oh, that's interesting. So when I find them, though, the ones that I see that are, a little dot on a page, a little period on a page, I'll occasionally find one working its way right into my skin that is, almost imperceptibly small. I know it's not fair for me to say this to you. What stage is that? Would I ever detect them at the larval stage, or would I more likely see them at the nymph stage?
You're more likely to see them as a nymph stage. You may see the larvae after they've fed. So the best way to tell, if you don't have a magnifying glass, is the time of year. So larvae are active in August, September. Nymphs are active in May, June, early July.
It would be that earlier time of year. So I'm seeing nymphs. So to his question, the larvae haven't had an opportunity yet to pick up these infections. So they're not congenital to them. They're not born with them.
Some of them are congenital.
Oh, interesting.
So it's biology, so everything has to be
There's
exceptions to the rule.
I want clean rules. Okay.
So for example, Powassan virus, it might be able to just carry over from generation to generation.
In other words, tick mom puts it to tick baby and the tick egg, and then they are born out of that with Powassan already.
Exactly.
Oh, that's kind of nightmarish. It seems like this tick story just gets worse and worse, the more you dig into it. I mean, I feel like there's a lot of people who are thinking like, oh, I don't really need to worry too much about this. And, I mean, you must encounter that a lot, right? Or do you encounter that? Are you mostly seeing people on the other side? You're already preaching with the converted.
We're seeing people from the other side that are terrified. They're coming out to see talks that we give in libraries and garden clubs, and they're afraid to leave their house.
Right.
So what we're trying to tell them is, hey, this is more akin to putting on sunscreen. You can take measures to prevent. You can do things to prevent yourself or minimize your exposures. And even after you've been bitten, because we test the ticks, we can give you very accurate information about whether you were lucky enough to have the 50% that's not infected, or you got the other 50%, and then you can take actions there as well. So we want people to know that they're all along the way. You're not powerless. There are things you can do, and people never make the right decisions when they're scared.
No, it's not a great place to decide from. Okay, so that dog tick has occasionally can transmit some illness. The deer tick transmits Lyme infection, Borrelia, as well as a suite of possible co-infections. And then how about the Lonestar tick and its ability to also, I want to say, and we'll go into the life cycle in a little bit, but you keep saying she because the adult deer ticks that feed on people are exclusively female.
That's right. The males don't feed. They just spend their time looking for females.
Does any of that carry over with the Lonestar tick, or is it a different story altogether?
No, it's the same story with Lonestar
So it'll be adult
ticks.
females. Yep.
And in the case of Lonestar ticks, there are pathogens associated. There's something called ehrlichiosis or Lichia. But the interesting thing about Lonestar ticks is they also have been associated with a food illness, an allergy to red meat.
Yeah, this is the alpha-gal thing.
The alpha-gal thing. So whether it's the alpha-gal is a sugar that induces this immune response, whether the sugar is coming from the tick itself or whether it's coming from a past blood meal or host that tick is fed on.
Okay. We don't know yet.
We don't entirely know.
Okay, so but the result can be a person who is now allergic to red meat for the foreseeable future, correct? I think I may have heard some story. Are there some folks who that's reversed for, or that eventually
it does go away?
Okay, in some instances. So we don't know much yet about this particular allergy.
Still learning more.
It's frightening to me. It's so frightening.
You're so calm for somebody who studies all this so in depth.
he's just used to having to be the calm one in the room when this stuff comes up, I think, Okay, so those Lonestar ticks are spreading into, where are they coming out of, and where have they spread, as far as if we're looking at a map of the United States and Canada, how much of the continent is sort of at risk from interacting with these ticks?
So 20 years ago, you could draw a line basically east-west from Washington, D.C. downward and over to the Mississippi. That was sort of the range of Lonestar ticks.
All the way down to Florida?
All the way down to Florida. Now they're as far north as Maine. You see them in southern Ontario. Okay. They're established populations here in Massachusetts. So there's a difference between an occasional tick that drops off and you see it because it dropped off a bird that was migrating, and actually seeing all three stages. That's how we sort of distinguish.
Like a breeding population versus an individual.
Right.
We always have this story up in Maine. There's people always reporting, seeing mountain lions. Yeah. And we're always saying, okay, well, maybe there's a mountain lion, but is there a breeding population of mountain lions, right? It's a big difference. How far west have they expanded? Are they still limited by the Mississippi, or are they making their way west?
No, they're creeping their way up into Minnesota and Wisconsin, where traditionally there have been black-legged ticks or deer ticks.
Okay. Wow.
There might be good news. So this is a little speculative, but there might be good news about the Lonestar ticks. So in places like Long Island, so again, we test We test people's ticks, so we receive about 15,000 ticks a year from all over the country.
Wow. Yeah.
And from Long Island...
15,000, you said?
15,000.
Wow, that's fantastic.
So 15,000 people that have been bitten by ticks send the ticks to us. And what we see is a trend in Long Island of less and less black-legged ticks coming from people and more Lonestar ticks. And the good news about Lonestar ticks is, despite the alpha-gal thing, there's very low infection rate. So you're not talking about 50% infection rate. You're talking about vanishing. This might be less than 2% with Ehrlichia. The fact that in Long Island, more people are getting bit by Lonestar ticks than black-legged ticks could be a good thing, because we know the infection rate in the Lonestar ticks is lower than in the black-legged ticks.
And you're alluding to, but maybe not wanting to say it outright, but is there some speculation that they compete with one another in some way?
Possibly.
For what? For
hosts. They're both feeding on deer.
Yeah, it's like I'm thinking about like how big the host is and how small the critter is. Do you think it would be, I mean, obviously you don't know, but do you speculate it's pure competition, or do you think it could be like with species of plants that maybe excrete a chemical that would, I mean, no idea right now.
We'd have to tease out also whether it's just that on Long Island they've had deer ticks for a long time. They're complacent about it and they say, oh, this is a different tick.
Yeah,
I'm sending that one in because
yeah.
there's a fee associated with the testing.
How many colleagues do you have out there around the country who are doing work like you're doing, looking at this?
There's a growing number of labs that are starting to test ticks. There's one in Pennsylvania. There's a lab in Arizona. One in Colorado.
Yeah. What kind of trends have you seen in the response of the medical community over the course of the time you've been working with ticks as well? Has their stance changed, and how prophylactic and or concerned sort of are they at this point about tick-borne illness?
Again, it varies widely geographically, but even within a so we work very closely with people on Cape Cod because we have a good relationship with Cape Cod County Extension. It's been sort of ground zero for deer ticks for 4 decades. And there you'll see a range of docs. From some docs you get bit by a tick, they're going to give you antibiotics straight away. Other docs will say, no, I really got to see the EM. I got to see or a positive blood test. EM is the erythema migrans, the bullseye rash.
Can you say that word real slow for me? It's like one that I have not ever committed to memory.
Erythema.
Migrans. Okay.
Or
and that would be
EM.
that bullseye rash that has been associated so much with Lyme disease.
Right. Yep. So some docs will wait to see that rash, which takes a couple weeks after the tick bite to show up.
Now, a lot of the people that I've spoken to, and I'll preface this by saying I'm knee deep in the alternative health world, so I hear a lot of things that turn out to be complete hocus pocus. But there's a real big push to get on an antibiotic, get on doxycycline within 2 weeks of the tick bite. So that idea of waiting 3 weeks to see if I get a rash sure seems risky, since that it seems that it gets harder to treat as time goes on. Do you have any opinion about that, or do you stay out of that side of the house?
So the prophylactic treatment is within 48 hours post-tick bite. So the idea there is to get a small dose of antibiotics real early after the exposure and to nip it in the bud, as it were, before it even becomes established. And there's very little controversy that the earlier you treat Lyme disease, the more likely you are to have a favorable outcome. So waiting a couple of weeks for a rash to show up, or waiting the few weeks that are necessary in order to be able to test humans, because the test for whether you got infected or exposed is whether you have antibodies, and that whole process takes weeks time, before it shows up. So when you ask, and I might be answering a question you didn't ask, but one thing we've seen is a change in the response in the medical community to testing ticks. So initially, because the CDC doesn't find value in tick testing, many physicians sort of shied away from it. I think there was a little bit of concern that...
What does that mean, the CDC didn't find value in it?
The CDC thinks that, or we are in agreement with the CDC, that the infection rate of the tick is not the sole factor that determines whether you yourself get infected. So if you get fed by this tick that's infected, a number of other things have to happen, including the fact that she has to feed for a sufficient length of time. Yep. So if she's fed for less than 24 hours, most likely, even if she was infected, whatever was in her never got into you. Mm-hmm. So the CDC is concerned that if people take a tick test to be a diagnosis of their condition, that they may be, in some cases, overdiagnosed.
Take a tick test. In other words, they get that tick tested. It shows up positive. It may never have transmitted anything to them. And so the CDC is saying, hey, that's not of much value to us.
And the alternative could be that the tick could test negative, but another tick fed them and they never had that one tested, so they could have got positive.
Right.
So all of this is part of our disclaimer. We tell people this isn't a diagnosis. But a growing number of physicians and individuals like the idea that they can assess the risk of the tick that just bit them, understanding that they don't know anything about the tick that they didn't find.
But the balance people are walking is taking antibiotics they don't need, which is a tremendous problem, obviously, that we have here in the country, and then not taking one soon enough. And if I understand the spirochete, it's sort of, once it's first moving in through the bloodstream, but then it's boring its way into places that aren't well vascularized, right?
Sure.
Yeah, so places that it's hard to deliver antibiotics to, right? So they can kind of hide out, cloaked away from these antibiotics that you take. And then now this is where it gets, actually, first I want to say, this idea that it takes 24 hours to transmit, I kind of like that as a general rule. It makes me feel much more relaxed about everything. But wow, if you say that to a group of like sort of Lyme people, wow, you'll hear all kinds of stuff. And there are folks who swear they got it in the first hour, 6 hours, and man, and it's difficult to sort through and navigate because the intensity of some of these folks, and sometimes I'll save you from having to say anything like it. I'll take the heat, but I meet some folks who verge on the mentally and emotionally unstable side, where I go like, does this have anything to do with Lyme, or is this sort of a diagnosis that's become like a big basket where a whole bunch of things all kinds of symptoms get thrown into the Lyme basket? Because I meet some people, it's like, man, that person's just not well. I don't know if it's Lyme or not, but they have no positive test for Lyme. They have no tick, that they've had analyzed. They never got a rash. They never had a tick bite, but they're convinced they have Lyme. And I'll be like, how do you know you have Lyme? And there'll be like no answer, right? So you must encounter that. But currently, this idea of 24 hours is generally accepted amongst people who study this. And what's up with all the crazies? Because there are, have you ever like gone around talking to people about any of this? Do you know what I'm talking about?
Not quite.
Dude, I've met some basket cases.
I believe it.
On the Lyme side.
So when I touch on a topic like that, as well as when I talk about the effectiveness of acaricides or pesticides, I usually predicate it by saying, I can't tell you anything about your lived experience.
Right, yep.
All I can tell you is the science that is available to me, and I can report on the best practices that science supports. Yeah. And if you found that rubbing motor oil on you prevents the tick bites, great. If you found that you got sick from Lyme disease after 15 minutes of tick feeding, that's your experience. I'm just telling you that when we collectively, scientists, do the experiments and feed ticks on mice, it takes 24 hours for the spirochetes to move the bacterium to move from that tick into the mouse. And these experiments have been replicated, and it's pretty robust.
There's no studies on humans that we've been able to do.
Well, what we're trying to do now is we are ostensibly doing those experiments when people send us the tick, so we can say this tick is fed for 24 hours. This one's fed for 48 hours.
How do you know that? That's based on looking at the tick itself?
Yeah, so they actually change both the dimensions and the relative ratio. Like there's something called the scutal index. This is a scutum.
Scutum, for people who can't see, that's that sort of thumbprint shaped.
The shield, also people call the dorsal shield. Yeah. Yep. So the length of this, or the relative length of this, can be used to measure how long the tick has been feeding.
So you can get an estimate. Bigger. When you say an average of 24 hours, what are the sort of extreme ends of that? What's the sort of shortest period of time that we've seen it disease transmission, and how long could it take?
I don't know the standard deviations of it, but it's 24 hours is sort
pretty
of
good guideline.
Is a pretty good median.
Okay, because that way I figure, like, if I check myself before I go to bed very thoroughly, and there's nothing there, and I wake up, and this happens to me all the time. I wake up and there's now a tick on me. Right. I know that I haven't been sleeping more than 8-9 hours. Mm-hmm. It's for sure not had 24 hours, and I don't feel that I got to start panicking. Like, if people start freaking out, and I'll go like, oh, even if it started to attach itself, I usually don't really get too concerned about that. because I know I've caught it in that time frame. So that seems like a fairly reasonable practice to you too.
Yeah, and there's independent of the empirical evidence of how long it takes for things to go from the tick into the person or the mouse in the case of experiments. We also know what's going on with the feeding apparatus, that the ticks aren't always spitting things. There are a large portion of that first 24 hours where they're sucking things.
Okay.
And so the direction is one way. So if they're only bringing things in, the likelihood that they're pushing stuff back into the host is relatively low.
Which is how you actually contract the disease, is that they're sort of regurgitating that stuff into the wound.
Yeah.
Tell us a little bit describe the process of how they feed. It's quite fascinating.
Yeah, it is fascinating. So they will bore themselves into the feeding lesion. Okay. They have chelicerae that sort of saw their way in.
Is that what these big mouth part things that I see are?
Those are the palps, and in that case, they're actually stuck together. In the middle, this is anatomically incorrect. There'd be 3 of those in the center. And then the centerpiece would be that little auger that they drill their way in. Yeah. And then these 2 would lay out laterally, and they'd secrete a cement from the end, and they'd glue themselves in place.
Oh, wow.
So the barbed mouth parts hold themselves. They make you feel itchy when you hear it.
On the car ride down, I was like, I think I have a tick on me.
So the middle piece is like the ice fishing auger.
It's actually barbed, yeah.
And it's barbed as well.
Yeah.
Oh, how brutal.
And it's hollow in the inside, so all the stuff's going to come in or out through that hollow center. And then they sit there, and then they've got salivary glands that come down the lateral side of their body.
Oh,
big, giant salivary glands. And
really?
then their gut.
So they salivate out of this exoskeleton that they have.
Oh, it's inside. It's inside.
Okay.
But
the glands are inside, and then
inside,
they excrete from where?
They excrete through the.
Okay, got it.
Through the hypostome.
Okay.
And so they're spitting and slurping and spitting and slurping, and they're preparing a little feeding lesion just below the skin that very late in the process, in the case of the adult female, 7 to 10 days into the whole process, they'll start slurping that up in the last 24 hours.
All right, so this would be like if I'm in the desert in an arroyo and I'm digging for water, and I dig and dig and dig, and eventually I get a wet spot, and then slowly it fills in, and I decide at the end I'm going to have one big meal.
Yeah, or put your canteen in there and fill it up.
Yeah, okay, so that's what they're doing. So this lesion is like they're just boring away and sort of scraping away a hole, and then they cement their mouth around that, so nothing else can kind of get in there. And
that's so they don't get pulled off.
Oh, that's the attachment.
That's the attachment part.
Okay, so when you pull one off, you don't see it, but you're overcoming like a glue bond. I assumed it was more of like the barbed type thing. I thought there was like barbs holding them in. So there is that.
It's a combination of the two.
But there is actually an adhesive.
Wow, that's crazy.
Yeah, that's fascinating.
Pretty cool.
All right.
Sucks, but it's cool.
So then the other part of that process is that inside, the bacterium are separate from that whole process. The bacterium were acquired from the last time she fed, which is usually 6 months to a year ago. When she was a nymph or a larva, she got infected, and they go into the midgut, which is this sort of collapsed garbage bag inside this main body. And when she was feeding, the collapsed garbage bag filled up, and she became replete, the word that you liked before. Yeah. And then she digests her blood meal, and that bag sort of collapses again.
So when I see that big swollen tick, that's because that bag is all filled up.
The bag is all filled up. And inside that bag, on the inside, are the pathogens, the bacteria. And they hang out, they stay in the midgut until such time as she has digested all that blood meal, molted to the next stage, and goes on to the new host that she's going to feed on. So while she's doing that process we just described, attaching, feeding, etc., the bacteria has to get out of that midgut, come through the hemocoel, which is the blood, the open circulatory system of the tick, and then back into the salivary glands, which is another reason that it takes a while for that process to take place.
Now, is she doing that mechanically? In other words, is she doing something that's causing those pathogens to make that movement, or are those pathogens making that movement opportunistically?
They're doing it on their own.
Oh,
and they're doing things like utilizing some of the blood proteins that they're acquiring from the host to facilitate that transmission. So plasminogen and other things that are coming inside the blood are a signal to the spirochete, to the that's the fancy word for bacteria. Saying, we're feeding right now. Now's our chance to get out of this tick and into another host. So they start activating, and they change expression of their own coat proteins, and they move through these different tissues.
So sophisticated.
It is. It's real biology. It's not just a syringe. It's not that this tick is going to suck something out and put something over there.
It's not just a mechanical plunger being pushed. Wow. Okay. The tick is not really the problem. It's these organisms and what they're. I mean, the tick is just a vector. Hey, we'll get right back to the interview in a moment, but first, domesticated, civilized living restricts the natural movement of your human body, forcing you daily into chairs, cars, and rigidly defined pathways. But when we head out onto wild landscapes, we carry these dysfunctional, domesticated movement patterns with us. MoveNat is a natural movement system that trains you and your body to move like a human animal again. Are you interested in building natural movement skills that'll improve your physical capability in the field and in everyday life? MoveNat's new Level 1 Fundamentals e-course is structured to help you re-educate your body using practical, natural movements that enhance fitness, function, and physical capabilities, all from the convenience of your home. Learn to move the way nature intended. I attended MoveNat's Level 1 and 2 trainer certification courses a few years back and came away with practical knowledge and skills that I use every day and that have changed the way I train and move across the landscape, vastly improving my overall mobility, coordination, and fitness. This new e-course is movement-rich with clear instruction. Its progression-focused methodology takes you from restorative mobility exercises to challenging movements. All ability levels are welcomed and accounted for. Enroll now at wild-fed.com/MoveNat for instant access to the full e-course. Again, that's wild-fed.com/MoveNat, MoveNat. Again, wild-fed.com/MoveNat for instant access to the full e-course containing 16 classes designed to be followed over 4 weeks with specific and measurable movement goals for each week. The course is self-paced and you'll receive lifetime access. MoveNat. I can personally recommend it. It's a fitness and movement system that's designed for the wild. Now, back to the show. Wow, okay. Walk us through the life cycle, if you would. And the reason I want to know, it makes me think back when I was a kid and I would see what I thought was a random moon. I'd be like, oh, it's a half moon tonight and it's over here. And then, next time I saw the moon, oh, it's a crescent, now it's over here. I didn't know that it moved through a specific arc from east to west. I didn't understand how the lunation worked, so it seemed random to me. Similarly, I think for a lot of people, they're not understanding why sometimes it's a very small tick they find on them, sometimes it's a big tick. It took me talking to you the last time we spoke to understand that what I was experiencing across the calendar year was because of their life cycle, if that makes sense. So we're encountering ticks at different phases at different times, and we have a lull, which I think lulls a lot of people into thinking everything's okay and the ticks are gone, and then all of a sudden the adult females are back out. Mm-hmm. So how does that all work? And if you could lay that out.
So let's start with the adult tick. So the adult female tick will fully feed on a white-tailed deer. She'll take 3 to 4 times her own body weight in ticks or body volume in blood. Wow. And then she'll utilize all of that once she's been bred by a male to basically lay eggs. She'll lay about 3,000 eggs in June, July in the leaf litter. And each of those will hatch out as a larval tick that will start questing around for a new host.
Will that male find her on the host, or will he find her somewhere else? So he's getting onto the deer,
yep,
and he's sort of navigating through all those follicles to find her.
Yep.
She must be putting off pheromones or something that draws in there. Mm-hmm. He gets there. What does that look like, mechanically, the two of them?
So mechanically, you notice that they don't have any external genitalia. Mm-hmm. His genitalia are his mouth parts. So he's going to yes. So he's going to use that to deposit his sperm into the female, and then
where on her?
It's down here.
Okay. Just for the people listening, it's right where you'd expect.
And so he's gonna
while she's feeding.
While she's feeding, so she spends her time. She needs blood to make eggs. He needs her to make babies.
Okay.
So he's looking for her, she's looking for blood.
Okay.
And if she finds the blood meal, she attaches, and he just can get on.
And then if they get to do that, then most of those eggs are viable. They will hatch.
Yep.
Okay, so then she feeds. Eventually, she just drops off at random.
Somewhere she'll drop off the deer and make her way down into the leaf litter where it's a little moister and a little more controlled environment.
Something that stood out to me the last time we spoke was I had said, when I see the tick drop off, this is probably more often dog ticks, but I'll see them drop off of my dog in the house somewhere, and they just are so fat and engorged, and their legs look so small compared to the rest of their body that I assumed she lacked mobility at that phase. But you were telling me, no, she actually can get around quite well and will find her way to her ideal humidity and temperature?
She's unquestionably slower than she was when she was flat, but she can still get where she's got to go. Okay. She has to.
Yeah.
If she's going to lay those eggs.
All right. So then what happens?
So then she gets in and she lays the eggs. 2,000 to 3,000 larvae come out.
Hungry, just out in the open?
Hungry leaf litter, down low, and they quest.
But she doesn't have to glue them onto anything or attach them to anything?
No, it comes out as a big mass that's about the size of her body.
And they come out as eggs? All right. And
she dies.
Okay,
she lays
so she
her
goes
egg,
off and dies,
Her 3,000 eggs then go looking, or her 3,000 larvae then go looking for a blood meal. Okay. If they feed on a mouse that's infected, they become infected.
So the mouse is the reservoir that you were talking about before. So the mouse is walking around with Lyme, but not affected by that, or is it affected?
Not affected.
Okay. And if they get on a mouse that doesn't have Lyme,
they don't get infected.
Then you end up later with that nymph on you, and you're good to go because that nymph does not have any infection.
Exactly.
But if it gets on a mouse, what percentage of these, it's white-footed mice?
Yeah.
What percentage of them is infected?
In endemic areas, it can be close to 100%.
That's terrible. That's terrible to hear.
So you got to hope that the tick feeds on something that's not, like it feeds on a raccoon, which has a lower infection rate.
So they will kind of grab on. Are they doing a similar strategy that we see adult ticks doing, which is sort of finding a high ground and just putting their arms out, waiting for something to walk by?
Yep. And it's called questing. So they don't fly, they don't jump, they don't fall from trees or any of those things.
Yeah, a lot of people think they drop out of trees. I've heard that a lot from people.
Yeah.
I'm like, I don't think so. I always see them just putting their hands out. But
we had someone describing in detail watching one from 200 yards spinning around, flying through the air. Like,
come on. That's because they had chronic Lyme. All right, I'm sorry. I'm going to get some flack for that, but I just want...
Will a nymph swell up when it feeds on a host, just like an adult will? And what stage does the tick need to be to make eggs? Does it need to be a full adult?
They need to be a full adult.
So they need to feed. They need to become a nymph and then feed, and then they can go on to be an adult.
Finish that life cycle. So all of that larval feeding takes place in August, September. They have to feed to repletion, meaning they have to get enough blood in order to do that next molt. So they have to get the full blood meal, get all bulged up, fall back into the leaf litter. They'll spend the whole winter in the leaf litter doing their molting and digestion process. Next June, July, they'll emerge as nymphs. They will have molted to the nymphal stage, and then they're ready to feed again. Do the same thing all over again.
Okay, so June, July is when they are nymphs. That's when I'm seeing them on me, those little tiny ones that are the size of a little bigger than a period on a page. That's a nymph. June, July. If that nymph gets to feed, then August, September, what happens next?
August, September was where they started from. August, September was the larvae.
That's it. Okay.
That gave rise to the following June, July nymph.
Okay, so it takes from August and September all the way around almost a year before they can go to that next stage.
Yep.
They overwinter.
That's right.
When do the big changes happen? Are they obviously not under the cover of snow, right? So when is that happening? Is that happening in the year that that August and September, is it happening during that year, or does it happen in the spring?
Probably the April-May time frame.
Yeah,
As the warm air is coming in.
I mean, is there something between the nymph and the adult?
No. So then the nymph is going to feed in June and July. Same thing, fall off in the leaf litter, and then molt, and then by either the fall, and we don't exactly know why this is, but either the fall or the following spring, they will emerge as adults. And they're going to feed and do the stuff we talked about and start the whole cycle over again. And there's 2 waves of them. And as I say, we don't know exactly. I guess the common sense is that they emerge in the fall as adults. And the ones that don't feed in the fall end up showing up in the spring. But we've often speculated that they may actually be 2 different cohorts. Okay. So there might be a fall and spring cohort. But.
Okay. So for the person on the ground level who's experiencing the ticks, they could have adult black-legged ticks on them in the spring?
Basically, from the time the snow goes away, which around here is usually early April through May, they could have adult ticks. Yeah. And then again, mid-October to December.
Yep. Okay, and then they're going to be experiencing the nymphs in that June-July phase. So it's basically, you got what are your down times? They're very short.
The biggest are August and July. So then you're going to get fed on by larval ticks, but they're the safest ticks because they don't have Lyme and they don't have many of the pathogens because they're born without them.
Safest, but not safe.
Not safe.
Exactly. I want to talk about you guys have some great guidelines for people, and I am very bad at violating them. And I think a lot of people listening are going to violate them, but that doesn't mean that they're going to let their kids violate them, or maybe their spouse doesn't violate them, or whatever it is. And I say violate them because I remember one of the things you would talk to me about was, hey, if you're on a trail and you stay to the center of the trail, these ticks are going to be largely on the vegetation at the edge of the trail. And doing the kind of things we do, hunt, fish, and forage, we're constantly off trail, right? My clothing choices are, I struggle to really like strap myself in, from my socks up to my neck, but I think these are important kind of guidelines. So what is it you tell folks usually about preventing, getting ticks on you in the first place?
Yeah, so we say the best way to keep them off is to blouse your socks or blouse your pant legs inside your sock, tuck your pants in. So because ticks crawl upward when they get on you. So if they get on your shoe, and that's usually where they start, they'll crawl up. And if they crawl up on the outside of your sock and then up to your pant leg, each step they're taking up is an opportunity for them to get brushed off or to fall off. If you have your socks just the way we usually wear them, then they crawl up the sock and then they're up the inside of your pant leg, and then they get into the parts of you that you may not be necessarily checking. Yep. Of course, if you're just very fastidious.
I get a couple on those parts every year, I found.
If you're very fastidious and you're checking them carefully, it doesn't really matter if you have that protection, because the important thing is just to get them off you. So this is a measure to make sure that they don't get on you in the first place.
Okay. Yeah, that makes a lot of sense to me, and I could see wanting other folks to do that. I do find that I catch them all, but it's because, man, it's rigorous. It's the big full-length mirror and the bright light multiple times a day. Otherwise, for sure, I would miss a bunch of them every year. I mean, they're just... what about using bug sprays, essential oils, all that kind of stuff? What do you see working?
Before going there, just one other practice is to wear light-colored clothing just so that you can see the
visible
tick against the back. It's not that they're less attracted to it or whatever.
Right, so you can just see them, yeah.
Sorry, go ahead.
No, you go ahead.
I was going to say you get home and take a shower. Is that a high likelihood that the tick's going to come off?
Probably not.
Man, they're sticky.
Yeah,
even when you said about them getting brushed off, it's like, wow, they stick pretty good. I bet when they're moving is where they're most susceptible. But yeah, they sure. I mean, sometimes they have not even really started to bite, but they hang on to you pretty good. I want to know too. So I come home. I know there's ticks on my clothes, and I'm not going to be able to find them, especially wearing camouflage. You got multiple earth tones all woven together. So I know they're there. How can I ensure through the washing, drying cycle that I kill them, or can I not? Are they temperature resistant enough that the dryer won't kill them, or?
They're pretty sensitive to temperature. So throwing them in the dryer is one recommendation, but it has to be for, I think, a solid 20 minutes before they actually kill. So you throw the clothes before you wash them in the dryer, although then if you've got brambles and stuff, that's not the best way to treat your dryer.
But you're kind of heat treating them first, then you do your regular wash cycle.
You can do the same thing depending on the weather. You can just put them out, hang them up in the hot sun, and that will also kill ticks.
They need the humidity and they need some coolness or something. Okay, that makes sense.
And they'll probably just want to leave that clothing anyways if you just put it outside? They're just going to cling on to it.
They'll probably cling on to it because it probably still has some of the good essence of you that they're still looking around for. If you have any good essence.
He doesn't. It's chorizo only. Okay, just kidding. All right, so... bug sprays. Does that work?
Bug sprays, two approaches. One are the repellents and the other are the acaricides. So repellents, although the name implies that they repel, basically they keep ticks off your skin. So DEET is the most effective. This is another point where I would tell people about their lived experience. If you want to rub peppermint oil on yourself because you think it's been effective, great, but there's not a lot of evidence that essential oils work particularly well. DEET, everything is measured against DEET as the best repellent. You can apply it directly to your skin. In the case of ticks, it doesn't keep the ticks from getting on you. What it does is it keeps the ticks from attaching. So if you're treated part of your skin, they'll come to the spot that's treated and then crawl away. You have to apply the treatments over and over again. Probably it only lasts for 2 to 3 hours, and then you have to reapply it. So it's not the best approach. The best approach is acaricides. So beyond repellents, treat your clothing with acaricides that kill ticks.
This is like permethrin.
Permethrin, yeah.
Permethrin. Okay, and so that's actually like an insecticide that actually kills, or I guess they're arachnids, but actually kills them they absorb it just being on?
They absorb it through their feet, and it's something like 2,000 times more deadly to the arachnids than it is to the people. So It's got a very, very good safety profile. Some people just refuse to use any kind of chemistries, but it's pretty good.
Well, yeah, it's just good to get all these things out there too, so that people know what their options are. Are there any others that I'm not thinking of here besides daily checks, bug sprays, the way we wear our clothes?
Clothing, acaricides, tick checks. And don't abandon tick checks because you've got acaricides or the right clothing. Right, Always do the tick checks on the kid. Use a mirror if you're doing it on yourself, or do it with a partner, because they get in places that you can't necessarily see, middle of your back or in your hairline or wherever else.
Let's talk about what to do if so you're doing your tick check and you find a tick. Let's start by talking about when they haven't even really started to do anything. I mean, I spoke to you before about what happens. Sometimes I'll pull one off and she'll have like a little chunk of my skin in those mouth parts that comes off, but she's not engorged at all. I know she hasn't been there long. But I'll still sometimes react to that. I'll get, like a swollen bump for a couple of days from something like that. But I know she hasn't fed, and therefore I feel real confident she has regurgitated. For folks who have that experience, is that a thing where you'd say, look, don't even bother sending your tick in? Or would you say, maybe you still want to find out, or maybe you want to find out just because you're curious about your area? I mean, what do you tell people with ticks like that?
We tell people that those generally pose very low risk, and we let them make the decision about whether they want to. So we can't say that tick isn't infected with one of those rare things that could be transmitted in a very short period of time.
Good point.
So we let them make the decision. And we just generally leave it at that.
Okay. Let's say it's a little more advanced than that. You find that tick a little later and you're seeing some swelling. And what do you call this whole, I would say, like if it was a crab, I'd call it a carapace. What do you call this? Because you said they're arachnids, but they're not structurally like a spider or something, right? They don't have an abdomen and a thorax and a head.
Right. They're a single body part. We call this the scutum.
Scutum. Okay. So you start to see some swelling in that scutum, right? Then what?
When you start to see swelling, it means that they probably have fed long enough that they start to be a risk of Lyme disease. And then we tell people that it poses a substantial risk. And you've got a choice. You can go to the doctor and maybe get prophylactic treatment, and that seems to be pretty effective.
And that's typically going to be 2 doxies
within 48 hours.
Is there any evidence of that? I've read different things, and I keep doxies at my house, and I've given them to people. And I have sat there with them while they researched, sitting there with the 2 doxies, and some stuff we see says there's really no evidence that does anything. Other stuff I've said, it says it works, and most people will go like, I'll just take them because why not? But is there any evidence about that?
So again, the science is pretty good that it does seem to be effective, but you always have people with their anecdotes. So you said it better than I, or you said it.
Okay, so talk about removing the tick and what's your ideal way that somebody would remove a tick?
The best way is to grip them as close to as you can to the skin, and then just pull up with even pressure. Yep. That glue will sort of release. You'll pull the barbs out. You may pull little pieces of your own tissue. Ideally, you get the whole thing out, and all's done.
There's usually like a nice satisfying snap noise when I get to practice on my dog all the time, and I get right down in there tight against those mouth parts, and then there's a little pop, and I'm always like, yes. Yeah. But occasionally you break one and it like smears all over your hand. It's disgusting.
When I was a kid, I remember we used to, like my mom and dad used to light a match and put that against the tick. Is there any...
No, don't do that.
Don't do that. You're going to just burn your dog.
You're going to burn yourself or burn your dog, yeah. Don't do that. Don't do nail polish. Don't do... people put Vaseline on it.
They paint it with nail polish?
They paint it with nail polish. They put Vaseline on it. There's others that I've seen a lot. People talk about putting dish soap on a cotton ball and then rubbing it on. And they say, they've fallen off all the time. The truth is that ticks fall off because they're going to fall off because they're done doing their job. So if that tick was coming off...
3 days later, it fell right off. I know I'm good.
And that's the key thing is, remember this, the 48 hours, the 24 hours. So you don't want to do anything that leaves that tick on you any longer than you have to.
It's like the moment you interrupt its feeding cycle.
Then there's the other thing. People are always like, you got to be careful. You might leave the head in. And
right. So
is that real?
Has no head for starters. This one is sort of That one has eyes, which
Yeah.
they don't have eyes. But it has no head.
That's great.
The only parts that are merged in
Friendlier
you
with
are these
eyes.
little palps at the very end.
Okay.
So these little things. So these are the things that people are talking about getting broken off. And if they're broken off, if they're separated from the tick, they're no longer doing that physiological process of pumping stuff out of the midgut into the salivary glands. They're just dead. So unless they already infected you, those mouth parts aren't going to infect you in the future. So you now have what amounts to like a little sliver of wood or a little splinter of wood, which will work its way out, or maybe you can
dig it out a little
dig and
bit.
scratch if you want, but probably best to just treat it, wash it topically, and just watch it, and eventually those mouth parts will work their way out.
I heard what you said earlier about how this is less of a mechanical thing. It's not like a plunger being pushed on a syringe, the way that these pathogens migrate out of the tick and into you. But do you run any risk of mechanically forcing that if you squish that tick on the way out or something like that?
That's another one of the myths about ticks. So they actually have a block in their pharynx that doesn't allow things to come the other way. So they can't regurgitate. They don't vomit. Things don't come directly from the... This isn't really showing. I don't know why I'm showing that.
Stuffed animal.
Remember,
Stuffed animal zoology.
The straw goes into that midgut,
Yeah.
and that's what they fill out. The salivary glands are separate. They're a separate
Yeah.
sac. That's how things come out. So the things that are coming out of the tick are coming out of the salivary glands, not out of the belly that you're squeezing on.
Good to know, and actually brings me to another question, because occasionally, like I said, when I'm taking off my dog, every once in a while I squish one, and then I've wondered, if I've created any problems by doing that. Why is it that when I go to the vet, they have a Lyme vaccine for dogs?
So just back to that. So if you squish one and you get the blood on it, you certainly want to wash your hands, just like you do anything else. So the Lyme vaccine that's available for dogs is available for people as well. It was available several years ago. It's been taken off the market. So one colleague of mine sort of quips that it's because dogs don't have lawyers.
Yeah, okay, that would make a lot of sense to me. Where's that headed, the idea of vaccines, and is there any...
There's a couple
Is there
of
any hope in that direction?
There's a couple different efforts out there. There's some people in the States that are working on. There's a trial going on in Europe now for a Lyme vaccine.
They're dealing with a significant Lyme problem over there?
Oh yeah.
Okay. So there's a sort of an idea amongst a lot of people I talk to that it had this epicenter in Lyme, Connecticut, and then it's spread out from there. You and I spoke about Otzi the Iceman having, spirochete genetics, Borrelia genetics in him, so indicating that this is a much older phenomenon. And then you've talked about it being around the world. So are we having any more of an epidemic here, or is the same thing happening around and it is pretty restricted to the Northern Hemisphere?
Yes.
Okay, so is this happening around the Northern Hemisphere? We're just hearing mostly about what's happening locally, or
hearing most about what happens locally.
Okay.
The erythema migrans, the one we talked about before, that bullseye rash associated with Lyme disease, was first described in 1911. So it was described long before the bacterium was identified. So in Europe by a Swedish scientist. Okay,
interesting. So I think maybe we'll move on to talking about the diseases. Grant, anything you can think of?
What are the chances that somebody has it and has had it for a long time and just hasn't detected it? They don't know.
So you were touching on this before. Yeah, so this is what you're going to. So we hear these stories where people say, I was misdiagnosed for 30 years and then finally I got the diagnosis. I had aches and pains and brain fog and all these other symptoms, and it took 30 years and then finally I got the diagnosis. Why were all the other 30 years worth of diagnoses wrong, and suddenly you want to believe that it was that case? I think it's one of those areas where you just can't really know. But everyone has an anecdote, not everyone, but many people have anecdotes about, I was misdiagnosed for years and years and years. I had symptoms that didn't test positive, so the test must be poor. And then eventually I got a positive test, and now I understand all those symptoms for all those years. The logic is kind of...
Well, so, and to clarify, like, this is I think what you're driving at, and what he's saying is, like, there's a controversy about whether there's anything more than the acute infection. So there's this idea of a chronic Lyme infection. Please jump in if I say anything here that's stupid. There's this idea that you could get it and then not be diagnosed with it, and then for years and years you carry it, and that infection continues to dig deeper and deeper into you, and you hear mostly about it, people talking about effects on the nervous system, central nervous system, but also joints and things like that. But then there's a whole nother school of thought that no, it's only an acute infection. And then that's what I wonder about. So if it's, because I don't have a dog in the fight.
Bit. Not that there's that they're only acute, but just that the chronic is more constrained, that it's not an inevitable that chronic symptoms will evolve from that.
But is the idea that at some point your body purges itself of this thing, or it would go on, you would continue to be a host, but that it would be sort of in remission?
So some of the more controversial science is that the spirochetes can change their form and hide away in tissues. So again, the science is not really in support of that, but the notion, some people say that they've seen these things microscopically, and that the changing of the forms can inevitably lead to these chronic symptoms down the way.
This is a weird thing that's been, this idea of these, what do they call it, pleomorphic organisms. This has been a argument going on for 100 years at least, right? This idea of that pathogens change form and insist, and they do this and they do that. And but we haven't, I guess it's hard to imagine. There hasn't been anybody looked at who's gone untreated with an acute infection, and we followed up to see how that disease progresses.
Well, they've done some interesting work in monkey models where they've shown that the spirochetes can linger long after treatment for long periods of time. Okay. So there is some evidence.
Now, syphilis is a spirochete, and that one does have long-term chronic effects if untreated, right?
It does. Yeah, it has multiple stages of. Okay. And it's a spirochete, so it's said to be closely, related at least to Borrelia.
Roughly.
Right.
I want to make sure your question got.
Do you recommend people get tested for Lyme if they think maybe they might have it? Like, can they go on and for years and not even show symptoms?
What we try not to do is practice medicine or give medical advice in any way, because we figure that's between people and their doctors. We try to tell them something about their risk of exposure. I liken what we do to people that test radon in their basement. So radon is a carcinogen. It's found in a number of basements, and you can test your basement to see if you've got that exposure. If you do have radon, you don't tell your oncologist, I have cancer, but you might have some information that describes that or explains that cough that you've had. And you may want to share that information with your doctor because he or she may make a decision to do things a little bit differently.
I would love to get to the bottom of this. For myself, just for my own mental
Do I have Lyme disease?
Yeah, I want to know, do I have Lyme disease? Would you, is true or false, current testing methods for Lyme in a person are poor, and or some of the tests are poor and some are better than others? Because is it not difficult to find out if you have Lyme from a blood test or tissue sample?
So it gets a little bit into the philosophy of what is disease, right? So if, sorry to start out there, but if it's...
whoa, we just went big picture.
If the disease is defined by a set of clinical symptoms, then all the tests in the world, positive or negative, aren't going to necessarily influence that. If the disease is defined as fever, achy joints, arrhythmias, whatever else, headaches, then that is the disease. And then this question is just, can you associate all of those symptoms with that bacterium? Is the bacterium causing all those things? Is there something else going on at the same time? You didn't have enough lunch. You got infected from something not related to ticks, or you got something else from the ticks. So that's what makes it so controversial to figure out whether you have Lyme disease or you don't have Lyme disease. Is some groups want to define very narrowly what those set of clinical criteria are, and others want to make it much more broad. Okay. And that's where the controversy comes. What troubles me a little bit is some folks want to have that broader definition and say they have Lyme disease, but it doesn't change the outcome, right? So insisting that you have Lyme disease and yet the same treatments that you would treat other chronic or acute phases that don't treat those instances, you gain no benefit by the insistence.
Unless that you then had some protocol with which you could use to knock down the load of bacteria, right? Then it would be invaluable to know.
Sure.
Assuming you could do that. I mean, because one of the things that I've seen people who I don't even know how to say it. People with chronic Lyme, air quotes, they often are going on long-term antibiotic use, right? Intravenous antibiotics, which is has major health side effects. I mean, my goodness, sometimes I wonder, how is that even worth it to live like that? I've seen folks who have some kind of, does this make sense, like an auto injector that they walk around wearing of antibiotics? Like that's hardcore, man. Wow.
So we try not to wade into that controversy.
Yeah, I don't blame you. Let's talk about the life cycle.
Our message is prevent, right?
Yeah.
Just never get there.
Yeah.
Let's just figure out the best practices to not ever get to that stage.
Yeah. Okay. Well, that makes sense to me. We were talking about a spirochete, and just for people listening, like, what is a spirochete, and what makes how does that body shape give them some unique opportunities in the body?
Well, most bacteria are sort of eclair shaped. They're little sort of oval shaped bacilli, but spirochetes are different. They're corkscrew shaped. I don't know that it necessarily changes their ability to infect. It's just a different shape, and they can.
Oh, I was under the impression that actually gave them access to parts of the body that bacilli had a harder time getting into, that they could sort of, because I always hear that they can get into the meninges, they can get into cardiac tissue, they can get into joints, they get into the central nervous system, and then they do so by boring mechanically with that body shape.
But lots of different body shapes can do something similar. Right. They have the same apparatus. They have different apparatus that do the same.
We're just cutting through the myths right now.
I like
just myth busting. Okay, great. Anything else you want to kind of say about Lyme? Because I'd like to talk about some of these co-infections as well, and just help people get a sense of what these things are.
Well, let's talk about those.
Okay, great. So you tell us where you want to start. Anaplasma, maybe?
Anaplasma is an interesting one. So it's a bacterium. It's not a spirochete.
Yep.
It infects the white blood cells, like we said before. So that makes it particularly insidious because it's hiding in the very cells that are meant to protect you. It's a completely different bacterium. So a test for Lyme does not have any correspondence to whether you have anaplasma or not.
And you could get anaplasma from a tick that does not have Lyme.
That's right.
Right.
Yep.
So the term co-infection is kind of weak because it's not necessarily it could be its own infection.
It's a little bit misleading, because they can occur independently, they can occur together. Sometimes they may have synergistic effects in terms of the types of disease they cause. We think that it's yet one more reason that tick testing is invaluable, because by and large, Lyme disease is pretty well known by most docs throughout the country. So if you go and get a tick bite, the first concern is Lyme disease. Logically, it's the most abundant, most common pathogen. Anaplasma, not so much. They're probably not going to do an anaplasma test if you've got a febrile illness. If you've got a febrile illness, they're going to test for Lyme. And they're going to say, you're negative for Lyme, if that were the case, and go forth, and you don't need antibiotics. But you could have anaplasma.
Okay.
So anaplasma is testing in ticks is another way of sort of raising that awareness in the conversation with physician and doctor.
Is this one that your body, let's say you went untreated for it. So you have a fever. I imagine, like a lot of fevers, that could range in severity up, and I'm sure probably could kill you, right? Or you might make it through to the other side of that fever. And then is that infection eventually beat back by your immune system, or will you live with it chronically?
So remember, the fever is part of the immune response.
Yep.
Your body heating up is a way to kill the thing off. So yeah, you can maintain infection after the fever because it can become chronic itself.
Yep.
It can kill you. It can be fatal. Or your body can clear it.
Okay.
By itself or in conjunction with antibiotic treatments.
Okay. And the same antibiotics that work for the Lyme spirochete, the doxy, will work for anaplasma. Right. Yep. Okay. All right.
And the reason I bring up the tick testing is very often people will say, well, doxy will kill all of these things. It's true, but you may not get to the doxycycline prescription unless there's indication of a pathogen.
Right.
And if there's counterindication of Borrelia infection, docs may avoid a prescription for doxy because the Lyme wasn't there and they've missed the anaplasma.
Yeah, and doxy is kind of a rough, antibiotic to take for no reason, right? I mean, you get some light sensitivity, right? You burn real easy in the sun. I mean, if you're an outdoors person and that's why you've contracted this, being, burning in the sunlight. I have just a memory of a friend. We were in Connecticut. We stopped at the roadside. She got up to pee. That night, I am sleeping. I wake up from a dead sleep. I pull a tick off me. I get up, turn on the light. It's a small black-legged tick. I wake her up. She goes, checks herself. She's got one. She tests positive. They give her doxies. And I remember her knuckles were just burned so deep from the sun coming through the windshield of her car, man. It was so bad. So anyway, it's been in my mind like, okay, I don't want to take that if I don't have to take that, but it's good to know that it will work across the spectrum. So if you had, if you were on a long-term camping trip, you're out in the wilderness for a month and a half by yourself, you've got doxies with you. This is a crazy scenario, but you get a tick bite, that doxy would work across the bacterial spectrum of tick infections.
Pretty much, yeah.
Okay. But unfortunately, there are organisms that are not bacteria that we could contract as well, right?
Great.
I know.
Just what you want to hear.
I want to save Powassan because that's the one that freaks you out the most, and I want to put that as the icing on the cake. The protozoa that we were talking about.
Babesia.
Yeah, tell me about that.
So Babesia is a single-celled organism that's not a bacterium. Its cells are a little bit more like our cells. They're eukaryotic cells.
Would it be a protist? Or? Mm-hmm. Yep. Okay.
Yep. Or a protozoan. And they live inside the red blood cells, as we said before. They can be transovariously transmitted in the ticks, meaning mom can give it to baby ticks.
Okay.
That makes it particularly insidious. Because it's just...
Must be... Yeah, that one, I would imagine, is much more difficult to try to clear on your own. So, I mean, being a parasitic organism like that, will it linger in the body or can you clear it?
Actually, your immune system, because it's sort of a slow-growing parasite, probably most people with competent immune systems, they sort of fight that thing off.
Okay.
It's one of the ones that tends to be like convalescent populations or kids with underdeveloped immune systems.
Symptoms?
Fever again.
Yeah.
So that's part of the problem is the symptomology is sort of
so similar across the spectrum of them.
And that's what's beautiful about the erythema migrans is it's diagnostic. There aren't too many things that lead to a bullseye rash.
Okay.
So sometimes it can be confused with things like certain fungal infections.
Yeah. Oh, ringworm.
Ringworm, sorry. Yeah.
Yeah.
I was drawing a blank. Yeah. So ringworm can look a little like the bullseye rash.
A little bit, yeah.
But this is an expanding rash that's
it gets
associated
quite
with
big,
a tick bite.
Right?
Yeah.
Okay, and then Powassan's the one. I went to a workshop. I have a friend who's a botanist, and he leads these plant walks, and we're there for a workshop one night, and he's got folks in from all over the country that are all going to be camping there on his property, and he gives a quick tick talk before going to bed that night, and he explains, don't worry, it's 24 hours for transmission, all that, and then he says, except in the, he's very clinical in his approach. He just says, except for Powassan, which has only been found in this number, but most people die of encephalitis. All right, everybody, good night. And then he walks off, and we're all just like dumbfounded, But this thing does seem pretty scary.
It is. So there is evidence that it transmits in 15 minutes.
It's like, can I just catch on fire and just, spontaneously combust? I mean, rather 15 minutes, it's over.
Yeah.
That's it.
It's caused encephalitis, which is swelling in the,
what
of
percent,
the brain.
we probably don't even know in what percentage of people.
No idea.
Okay, and he had told us that night that the lethality was very high.
That's because they're counting people that show up in hospital with encephalitis. Okay. So if you show up in encephalitis with a viral encephalitis in a hospital,
now your chances are very low.
You're in trouble.
But it's only if you got to that stage. So we don't know yet how many people don't get there.
Precisely.
Okay.
What we do know is when we go to certain sites, again on Cape Cod, probably Cape Cod listeners aren't going to hear this, but there are sites that we can go to where there's upwards of even 10% of the ticks that are positive for Powassan.
Oh, that's hard to hear.
But we're not seeing 10% of the people suffering. So it's suggesting that maybe it's a little more widespread in some areas, but it doesn't cause disease to the extent that that's commonly believed.
And that's viral. Is there a treatment?
There's antiviral therapies, but
yeah, wow.
Once you got swelling,
don't get it.
Yeah,
don't get it. Mm-hmm. Right, you got that, Grant?
Good advice.
Tick checks.
Tick checks.
It takes discipline, man. It takes commitment. I guess
there's a funky thing just to mention about Powassan virus.
Please.
So, Powassan virus was named for the town in Ontario that it was first identified, Powassan, Ontario, and it was associated for many years with these woodchuck ticks that don't often bite people. What's made it particularly insidious, just to keep you a little on your toes, is that there's now a new variant.
I'm on my toes already.
There's a new variant that's associated with deer ticks, and that's what's made sort of more concern about it. But it doesn't seem to be any different in terms of its clinical manifestations. It probably has some of the same outcomes, but it can be transmitted by the same ticks that transmit Lyme disease.
And then lastly, I want to talk about the service you guys offer before we wrap up. But I guess lastly, I just want to ask, what's known about this alpha-gal allergy at this time? Do we have any idea how long that takes to transmit from? Is it's all unknowns at this point? He's
I don't want to say
shaking his head at me. It's like, oh no.
I don't want to say it's all unknowns, but there's lots of questions about whether, as I say, whether it's originating from the tick, whether it's associated with a particular species of tick. It does seem that there's a geographic correspondence, so it's predominantly in the southeastern United States, although the ticks are now expanding northeast, and we don't see as many cases of red meat allergy there. So could it be that it's just the ticks that are feeding on mammals in the south?
Yeah. Could
it be that it's just particular mammals that are feeding ticks, and so maybe eventually we're going to start to see similar symptoms?
Sure. Is it related to southern barbecue? That's not even a red meat. Pork. Yeah, pork's going to fall in that, right?
Brisket, maybe.
Yeah. TickReport.com. You guys have just this incredible service. I really want people to know about it and take advantage of it. So tell us kind of what that looks like. If you were going to go to the website, walk through the process, send a tick in, get it back, how much does it cost, all that kind of stuff.
Yeah, so it's what we do is we test the tick, we assess the feeding status, as we've established that it's very important to the feeding status, and the tick species. So not everyone can tell the tick species apart, so that's the first thing we do. All of those are determinants of risk. So you can use that to assess how risky the tick bite that you just had. We have ticks that come in that have been infected with Babesia, Anaplasma, and Borrelia, and the Lyme disease spirochete. So that's a very risky tick that you'd probably want to talk to a doctor about. The way it works is you can order a tick report online, TickReport.com. You give us your information. Then you send the tick. We reconcile the information with the tick, and then within 72 hours or 72 hours rather, we get the results back to you with the species, the feeding status, and the infection status. Then you can make a decision, an informed decision about what you want to do next. Is it worth the trip to the doctor? Do you want to change the conversation you have with the doctor? The doctor says this tick is no risk because it's a dog tick. We can tell you, because docs get it wrong, we can tell you, no, this is in fact a deer tick. Okay. Or if the doc says you really ought to have doxycycline because you just get bit by a deer tick, and we say, no, that's in fact a Lonestar tick.
Or that's a tick that has no infection.
That's a tick that has no infection.
Right.
So we let people, we're hoping that we empower people and take away that fear factor.
Yeah. What are you guys getting for?
So we do a couple different testing packages. We do one basic package that tests for the 7 most common pathogens. We add a next level with Powassan testing, and then we call it a comprehensive test where we test for 19 different things. It's $50 for the basic level, $100 for the next, and $200 for the others. But we partner with different states and different towns. Last year, the state of Massachusetts, through a grant from the CDC, subsidized. So it was $15, I think, for tick testing for the residents of Massachusetts.
That's awesome.
So
how do I get my town on board with that?
Call your health agent, have him or her call us, and we'll get on.
I mean, I think the price, though, still, most people have a copay anyway. These are really reasonable prices, $50, and you can get that sort of peace of mind, or at least have information to I guess, sort of bring to your doctor and problem solve that with them. So, yeah, it just seems like a great service and a great price.
You have a mobile app now as well, right?
Yeah. So it's a work in progress, but basically the idea is that you can point the mobile app, point your phone at the tick, take a picture of it, and within 10 minutes we can give you back information about at least what species it is, so you can make the decision about whether you want to get it in the mail and pay the $50.
Great. Also some great videos and stuff on your website as well. So, well, what do you think? Stay away from ticks.
Stay away from ticks.
But we're going to be right
checks. That's really what it comes down to.
That's what it is, because we're right in the middle of it all the time. Digging down into leaf litter, covering ourselves, like hiding around and everything. Bad idea. Dr. Rich, thanks for your time today, man. I really appreciate you talking to us.
Thank you. Thanks for coming down, guys.
Thanks for listening to the WildFed podcast. You can help us grow this show by subscribing and leaving us a rating and review. It ensures better rankings and more advertiser interest, which translates directly into better shows, more awesome guests, and a constant stream of fresh, new content. Have a question you'd like answered on the show, or a hunting, fishing, or foraging trip you'd like to host us on? Email us at info@wild-fed.com. And be sure to visit our website, wild-fed.com, to check out the WildFed video show and store. WildFed. Food is all around you.